So, amino acid is the building block of protein. So, amino acid is an organic molecule. So, yeah, we can easily remember the structure like this. You know, the carbon in any organic molecule has 4 bonds. So, I'm gonna draw 4 bonds for this carbon. And you know, amino acid, when I say amino acid, it indicates there is an amine group. So one bond is bonded to an amine group, which is NH2, and the other bond, as the name suggests, acid. In organic molecules, the acid is usually carboxylic acid, which is COOH, which I have drawn now. So the rest of the 2 bond, one contains hydrogen and the other contains an R group. So in nature there are 20 amino acids. So in each of the amino acids, this R group varies. Okay, for example, if it is a glycine, the R group is only a H. Okay, so the R group contains CH, OH, like NH, anything. Okay, it differs from amino acid to amino acid. Okay, so for Welsh, what people you should know, at pH 7, the amine group, you know, the amino group contains, or it has the property, it has the alkaline property, right? So what it will do, it can accept hydrogen and it can become NH3 plus. Okay, so this can become NH3 plus, and if we talk about the carboxylic end of this molecule, it will lose a hydrogen, so it will become CO4 minus. Okay, one negative here, one positive here. So this type of molecule at pH 7 is given a name zwitterion. Okay, so this is what you should know about the structure of amino acid. Okay, and also you should remember, in some of the amino acid, this R group contains polar groups. Okay, and some of the R group contains non-polar group. This will help to understand the structure of some proteins later on. Okay, now let's see, you know, as I said earlier, amino acids are the building blocks. Okay, they form the polymer. So when amino acids, like for example, let's say these 1 amino acids, when they form bonds between each, okay, they will form a polymer. So in here, the polymer is called the polypeptide. Okay, so I'm gonna write polypeptide because the bond between this amino acid is called the peptide bond. Okay, so now let's see how this peptide bond forms. If you can remember, in carbohydrates, when they form polysaccharides, they form bonds between 2 monosaccharides, right? So what is the bond that forms between 2 monosaccharides, if you can remember, recall? Yeah? Okay, that is the glycosidic bond. In here it is peptide bond. Okay, so now let's see again how the polypeptide chain is formed, or the peptide bond is formed. So you know, if I summarize the structure of amino acid, they have NH2, COOH, okay? And let's say, just to differentiate, I'm gonna use R1 in this amino acid 1, and in the next one I'm gonna use like same COOH, H, and here, just to differentiate the amino acids, I'm gonna use R2. Okay, so in carbohydrate, when the monosaccharide forms a bond between two monosaccharides, they undergo a condensation reaction. So what does condensation reaction means? It should lose a water molecule. So in here, they will lose a water molecule. So just to illustrate what happens here, I'm going to draw this. So you know, OH is there in the carboxylic acid, and H from the amine group will release a water molecule. Okay, so that's why we call this is a condensation reaction, and then they will form a bond between these two. I will write down the structure again. So I'm going to repeat this here, H2N. See, nothing happens here, so I can write it as it is, CO, and here this OH and H is released, so the remaining is this. So I can join this part to this molecule. So I'm gonna write NH is here, CR2, and H COOH. Okay, so this is the new bond formed between these two amino acids, which we called as peptide bond. Okay, so as this molecule is formed by two amino acids, I can call this molecule as dipeptide molecule. Okay, so I'm gonna erase this. So this is a dipeptide molecule. So when they form polypeptide, you know, there are loads of amino acids will bind together using this peptide bond, and then they will form a polypeptide chain. Okay, like this. So these are peptide bonds. Okay, so just a quick exercise, not actually, just to see whether you understood what I say. So here, let's say these circles are amino acids. If there are 3 amino acids, there will be 2 peptide bonds. Okay, so the number of peptide bond is n minus 1. N is the number of amino acids. Okay, right. Okay, now let's move on to the next, the structure of proteins. Okay. Okay, so you know, like some proteins, they have a very simple structure, some have very complex structure. So to do their function properly, they have to undergo some levels. Okay, for example, if you think of a student, they first go to the reception, and then primary, or the key stage 1, 2, and then secondary, and then they go to uni, and then they finally get a job. But some people, they drop off from secondary, and then they follow some other courses, and then they become a job person, right? So likewise, the proteins, they have their very simple structure is called the primary structure. So primary structure is nothing but the sequence of amino acids. For example, if I indicate the amino acids using different symbols, like say this is one amino acid and this is another different one and this is another different one. So the primary structure is like the linear chain of the polypeptide. Okay, so the primary structure will depend on the number, the order and type of amino acids. Okay, so we can easily remember not, okay, number of amino acids, order of the amino acids, that means sequence, and the type of amino acid. In one word, these three can be stated as a specific sequence of amino acids. Okay. Okay. So if I have structure like this protein is first one is different from the next one, because although they contain the same number, same type, the order is different. Okay, so if any one of these differ, that means that is a different protein. Okay. Okay, we'll learn about how the primary structure is determined when we talk about the protein synthesis. Okay. Okay, now let's see the next level, which is the secondary structure. So the secondary structure is formed by the hydrogen bonds formed between, if we think of an amino acid, they have CO, right, of the acid group, and they have some molecules here, some elements here, and they also have NH groups. Okay, so in Cl group there is a very tiny delta negative, because the oxygen is more, it can attract the electron more in the bond, and then they form a partially negative charge, and here hydrogen has a very smaller or partial positive. So these partially negative and partially positive forms a weaker bond that is called the hydrogen bonds. Okay, so when they attract, what happens if we think of a polypeptide chain? Let's say this is a polypeptide chain, and they have oxygen here. Okay, I'm gonna write it down. Let's say CO and H. So delta negative, delta positive. So they form a bond. So that, like here, they attract each other. So what happens there becomes a bend, right? Okay, so that's how the secondary structure is formed. So there are two types of secondary structure. The first one is the alpha helix. So this is a simple model of alpha helix. So there are hydrogen bond between these. Okay, that's why it has formed a alpha helix structure. Okay. And the next one, so let's keep this here. And there's another type of secondary structure, which is called, so I will write down the name. So this one is alpha helix. Can write this. And this one, so they are like folded. If you open up a book, and if you keep many books there and continuously, it will form a shape like this. So there are hydrogen bonds between these. Okay, so this is called the beta plated sheet. Okay, I will write down it clearly. A beta plated sheet. Okay, so this is the secondary structure, and now let's move on to the next level of proteins, which is, usually primary, secondary, and then should be tertiary. Okay, so in tertiary structure there are different types of bond in addition to hydrogen bond. So there is hydrogen bond, and remember in your exams don't write H bond, you have to write fully hydrogen bond. Okay, I'm just writing it to save time. Okay, and you know how it forms, and there's another bond, disulfide bond. Okay, so disulfide bond is formed between sulfurs in two different amino acids. For example, let's say this is a chain, so in the chain there is an amino acid which contains sulfur, like methionine or something like that, SH, and there's another chain to also contain, let's see, H is here, S. So these two sulfurs form a bond between these two. This is a covalent bond. Okay, so covalent bond is formed. So this is called the disulfide bond, and this is also called a sulfur bridge. Okay, so this is stronger than the hydrogen bond. The hydrogen bond is comparatively weaker, but there are loads of hydrogen bonds together. They are also strong, but it is not strong enough like this disulfide bond. Okay, so that is the second type. The third type is the ionic bond. Okay, ionic bond can be formed between ions. So for example, if there is an ion NH3 plus somewhere in the polypeptide chain, and somewhere here is double minus, so they are electrostatically attractive. This bond is called the ionic bond. Okay, and number 4, hydrophobic interaction. Okay, so hydrophobic, what is hydrophobic? If you can remember from what you learned in the plasma membrane structure. So hydrophobic means they repel water. So some R groups I said earlier, they are, okay, I'm gonna erase this, they are non-polar. Okay, so these non-polar groups, for example, I said this is the polypeptide chain, and there are R groups. So in here, R group contain only CH2, CH3, like these non-polar groups. So these non-polar groups cluster together and then they repel water.